so now we're going to look at all that entails one of these questions now. Okay? So what I would suggest is just take out, you need a separate piece of paper, maybe on your graph paper or whatever. Just take it out for a second. And we are going to look at all the question, all the information that's needed. So there are 4 things that we absolutely have to start this question with. And I want you to write this down. First one is defining statement. We have restrictions. Okay. So we need these 4 things. And I notice I left spaces there because I want to write below them. Okay? All right, now, all of these questions are set up such that we want to find the maximum or minimum. So when we shade the region, you have an inequality, right? And so you have a greater than or less than or a greater than or equal to or less than or equal to, right? Well, we want to find out, our objective statement deals with finding out the maximum way we can do things or the minimum way we can do things. It doesn't change. This statement right here is going to be an equality. So it doesn't matter if I'm looking for the maximum or minimum. I write the statement out as an equality, and then I use my critical points to solve it to find out what the solution is. Okay? So the defining part of this, the defining statement of the variables in your model.
Excuse me, those students who are going on the Yorkton trip, go to the back door right now, please, and load on the bus. Thank you.
The defining statement is, what are X and Y? That's it. What do X represent? What do Y represent? So let's look at the example, and then we'll work through the example, and so it makes a little more sense. 4 teams are traveling to a baseball tournament in cars and minivans. So X is number of cars. Y is the number of minivans. And there's my defining statement. All right? That's all we have to put for that. My restrictions, that's this guy. This is where I put what we learned yesterday. Can I have half a car, a quarter of a car, a tenth of a car?
No.
No, I can't. So what does that mean my restrictions are then? Nearest whole number, exactly. So I write that out as such. X is an element of my whole numbers, and Y also has to be an element of the whole numbers. So there's my restrictions. Okay? So I either write it as real numbers, integers, whole numbers. I guess there is a case that could be natural numbers, but we don't use that. What's the difference between whole and natural numbers? Does anyone know? Difference between a whole number and a natural number? Yeah, exactly. Whole numbers include 0, natural numbers do not. Okay? So far, so good? So the defining statement, just tell me what X and Y are. The restrictions, that's where you decide whether it's an integer, a whole number, or a real number, okay? All right, the constraints. This is the bad boy. This is the guy that is important to us because this is where we shade. So we got to get that equation right. So let's read this question now. Each team has no more than 3 coaches and 10 athletes. So we have 4 teams, 3 coaches, 10 athletes. How many people is that total possible people? It's 13 per team, 4 teams, 52. So combined, we know that the total is going to be less than 52. Less than or equal to 52, right? But X is cars and Y is minivans, so we don't need to worry about that just yet. Each car can take a team of 5 team members. No, let's try that again. Each car can take 5 team members. There we go. And each minivan can take 8 team members. No more than 5 minivans and 11 cars are available. The school wants to know the combination of cars and minivans will require to the maximum and minimum number of vehicles. Create and verify a model to relate to this situation. Okay. So a car can take 5 people. A minivan can take 8 people. So I'm going to skip right to my objective statement for a second. All right? My objective statement is I want to know the maximum or the minimum number of vehicles that I need. Now that's based on the number of players, right? So how many can I fit in a car? 5. So for every car, I have 5 athletes or 5 team members, right? They try and confuse you with coaches and players. So
Does that mean maximum?
M just means maximum or minimum. Doesn't matter. I put M there. Okay? Sometimes it'll be profit. All right? Sometimes it'll be revenue. Y, how many people can I put in a van? 8. So my objective statement is this. To find the maximum number of vehicles I need, I go 5x plus 8y. And x represents the number of cars, and y represents the number of minivans. Now I have to look at my shaded region. What my shaded region gives me is what I call critical points. That's the word I couldn't remember yesterday. I know it's a big word. Couldn't remember it. Okay? My critical points come from my intersection points. So if I was looking at this graph in particular that we drew, there's one intersection point, there's a second, and here be a third, but that one's no good because it's outside our region. If I was looking at just the whole numbers, that's what it would be. If I was looking at real numbers, I'd have to add this guy in. And I wouldn't use these two. Okay, so those are what we call critical points. So critical points are where the lines cross each other or where they cross the axes. So the x and y axes, okay? And then those critical points will make a region. Whether it's a triangle, whether it's a quadrilateral, whatever it is, okay? It makes a region. All right? So let's look at our constraints now. No more than 5 minivans. How do I show that? Minivans is...
Less than or equal to 5. Something like that.
Yeah, that's
Something like
100% correct. Okay? So is it x or y though?
Well, why?
Y. So in this case, y has to be less than or equal to 5 because there's no more than 5 minivans allowed. What's the maximum number of cars I can use? 11. So how do I write that?
Maximum less than or equal to 5. Or 11.
11. All right. We've got one more. This is where the total number of athletes comes in. Okay? So I'm going to take the number of the cars times by 5. I'm going to take the number of minivans, I'm going to times it by 8. And that gives me the total number of people. Do you agree? So 5 times 1 car would be 5 people. 5 times 2 cars is 10 people. Right? 8 times 1 van is 8 people. So I need to have, what was the maximum number of people I could have? 52, right? So how would I write that down so that I have an inequality relating to that 52?
X plus y is less than or equal to 52.
Okay, good start.
No.
Real good start. What's he missing? He said x plus
5x
what?
plus
Yes.
y is equal or less than or equal to.
It's the same as this here, right? So it would be 5x plus 8y has to be less than or equal to 52. I might have this wrong. Let me just make sure. My objective statement. I do have this wrong. Sorry. I don't need the people in this one. So just change that for me, please. Cars plus minivans, that's my maximum number. Cars plus minivans is my minimum number. The people don't matter until I do this here. All right, so far? Okay. So somebody asked me, or somebody made a statement, well, we should never get this wrong, right? Now, because realistically, you can pull out your app. So let's do that now. I want you to graph these three on your app right now, please. I'll do it on this guy. So it's y is what? Less than or equal to 5?
Yeah. X is less than or equal to 11. See a lot of funky colors here.
Okay. And then 5x
Plus 8y
plus 8y
is less or greater than 52.
less than or equal to 52, right?
Yeah.
There you have it. Okay. I don't know how yours looks, but this is what mine looks like right here.
Yeah.
Okay. Oh gosh, that's hard to see. That is a terrible color of green. Okay, is that a little bit better for you?
Yeah.
Okay, so you have this, does anybody not have this in front of them right now? Because I want to, all right? So all that 6.4 is asking you to do is this right here, basically. All that 6.5 and 6.6 are going to ask you to do, I think there's a 6.6 in here. All they're going to ask you to do is finish the question off by finding your critical points, putting them in the optimizing equation, and solving. So here's how this finishes. So can you just put your graph down for 1 second, please, and I want you to watch the board. It's only going to take me a second to do this. All right, my critical points then. If you look, my shaded region is actually,
It's that.
Well, it goes further, but it has to be whole numbers because you're driving minivans, not negative minivans, right?
right.
Why did you keep going up there?
Sorry?
Like, right there, why didn't you keep going up?
Because it has to be less, remember your cars has to be less than 5. That's this line right here, this purple.
Oh, yeah.
Here, let me do this again, and let me show you again, and I'll do it so you get an
There's still
understanding.
more green up
So-
there is what I'm saying. Like,
Yeah,
there's-
no, this, look at this here. This will make this look better. So I delete my graphs here, right? Okay, so there's my outline right there, right?
Yeah.
Okay, so now I'm going to go y is less than or equal to 5. Okay? Okay, voila. So
Oh, okay.
that's within that realm, that region, right?
Yeah.
Now I'm going to go x less than or equal to 11. There.
Okay.
So it still extends out, you know, like it's past where my shaded region was. But now I've got to do the 5x plus 8y is less than or equal to 52, right?
Yep.
Okay, and that should give me right along that line, that slanted line there, just like that.
Okay. Oh, I didn't see the other shaded part underneath. Thought you were supposed to keep going like red more red.
Okay, does that make sense? You okay then?
Yeah.
Okay, all right, so grab the device. Find me these 4 critical points, please. Find me these 4 critical points. So the critical points are the ones that are,
Should we write them down?
yeah, you're gonna, okay, let me show you where you should write them. Here's what I want you to do with those critical points. Everybody just quick look here. Go like this, please. X, Y, and make a third column for M. Okay? So I want you to put your 4 critical points on a chart right below your objective statement.
And the X is where it is on the X-axis.
No, it's coordinates. So I want this coordinate. I want this coordinate. I want this coordinate and that coordinate.
So we don't put anything in M right now?
Not yet. I'll explain that in a second. Okay, so what are my 4 coordinates?
0, 5, is that one?
0, 5 is 1. Yeah, good. What's another one?
Is it 10.4 and 0? I think.
Yeah.
Well, you should be able to push on to it, right?
Well, these ones you have to zoom in because it
Is
doesn't.
1 2.4, and then 5?
2.4 and 5?
Yeah.
Yeah.
The blonde one.
2.4? That's this guy right here?
Yeah.
Yeah.
He's 2.4 and 5?
Oh, I went to this other one down here.
Yeah, 2.1.
That one's good.
No, you know what? I got a problem here. No, I don't. That's right. What's going on here?
1, 0, 0.
Yeah, 0, 0, I guess.
It won't show.
I think our boundaries are not.
I definitely thought the purple is what we were shading in.
Yeah. According to this, that's what you are shading in. Well, no. Okay, well, let's make sure our equations are right. Oh, you know what it is? They got it wrong in the book, that's why.
Do they?
Because they had the cars is less than or equal to. Oh, no, I got it wrong here. Okay. We've got this statement wrong right here. Oops. Maybe we don't. Maybe we have it right. I just didn't type it in right here. Okay. We have to have y is less than or equal to 5. We've got that. X is less than or equal to 11.
No, but it's 11 cars or 11 minivans?
It's cars.
Oh, that's right. But is there cars?
No.
Maybe the book is wrong. Maybe look at the
Oh,
cars,
they have
the
it
Y.
right there.
No.
Okay, so they've got y is less than or equal to 11. No, cars is less.
Their cars and minivans are correct.
So 5 times cars plus 8 times minivans. Everything looks right. Why is it not giving you the same thing as theirs? It's somewhere along the way we've got an error here. Where is it?
It looks like we only have 2 things scrapped.
No, that's not right. Cars is less than or equal to 11, so that's x is less than or equal to 11. Minivans is less than or equal to 5. 5x plus 8y is less than or equal to 52.
Stumpy dumpy.
0 to 11. No, they've got that switched.
0, 0, 0, 11.
Yeah, like they're 0, 0, 0 to 11, 1 and 11, 5 and 3, and 5 and 0. I don't know.
Maybe they didn't zoom in. I don't know.
No. Okay, how do they, there's no way you can get 0 and 11 out of this.
Yeah.
Oh, you know what it is? I think
It's
we've
not
got the
that
wrong
bad.
shaded region, that's why. Okay, let's do this in order. I'm gonna do this a different way. Let's try this again. Let's make sure we've got this right. So, no pen and paper. Okay, so along our so we've got cars. We have to have less than 11 cars, so that is right here. So that is 11 and 0, right? And we have to have everything over on this side. So let's shade it this way. Like that. Okay? My minivan, which is Y, is 0 and 5. So that's 0 and 5, right?
And 0 and 5 is one of our points.
So that region is shaded this way. So we're talking about this. Okay, now I'm gonna change that. I'm gonna use my intercepts. So I'm gonna go 5 times 0 plus 8y equals 52. What's 52 divided by 8? 7, it's gonna be 6.5, right? So that's 6.5, so that's right here. Okay, and then let's take 52 divided by 5.
10.4.
So that's right here.
And that's one of our points as well.
Yeah, and our line is
It's the same thing, is it
Or
not?
10.4 and 0.
exactly what we had, is it not?
Yeah.
Okay, so 0 and 5, that point there, this coordinate here, and that coordinate
Yeah.
there.
Yeah.
Okay, that's what we get.
Look, Sean.
They
Yes.
round it, I think they rounded it to like the next whole number.
Because of that's what you think, because of the
Yeah.
vehicles?
I don't think
Okay.
so. Even our court, even.
Okay, so 0 and 0, so this guy would be, so this would be 10.4 and 0, right?
So then it rounds to 10, not 11. But I'm not sure.
But they don't even have 10.4 and 0, they have 5 and 0.
Or they have
I think
0 to
they've
11.
flipped their X and Y's, is what I think's happened here. Okay,
Yeah, that's.
all right, let's, hypothetically speaking, let's just go through with what we have here. So let's use your coordinates. So one of my coordinates, I'm gonna go back to this.
How do they have
So I'm just gonna show you how, let's go ahead.
They have 5 on there.
I know, that's what I'm saying, because then I think they've switched their X with their Y. Okay, you too, right. So I've got 0 and 0. So I put it into my equation here and I get 0, right?
Yeah.
My other one was 0 and 5, right? So that means I have 0 cars and 5 minivans. So I have 5 there. Now just think about it for a second. What's 5 times 8?
5?
5 times 8. 40. So, but I can have a maximum of 52 people, right? So that means then that I've only got 40 people going, so this can't work for me. All right? One of the intersections, what you're gonna find is the intersections that are in these types of areas where the lines cross, those are the ones that are gonna give you your maximum and your minimums. So what was this coordinate here?
2.4 and 5.
2.4 and 5? So that would give me, 7.4 vehicles. Right? So 40, right? And 2.4 times 8 is what? 2.4 times 8.
3.2, 16, 19.2 with it, 12.
19.
That's what I figured.
19.2? So 19.2 add 40 is what?
59.2,
What is it?
59.2.
All right, is that a plausible answer for this?
No.
No, because we have to have less than 52 people, right? Okay, so technically if I had, what if I had 2?
Yeah, like round it down.
If I round it down, that gives me how many possible in the van? 16? And 40, that's still over 52.
So how come that's the point?
times 5 and most of them say, I guess.
Well, we've got, because the minivans can carry 8 people.
Yeah.
No.
So that's 40 in the minivans.
Yeah.
And then we can, by 10, right? That's what you're saying. Right. We should have times this by 5 instead of 8, which gives you 12, which gives you 52 right on. So this is the, if you have the maximum number of players and coaches, you're gonna need at least 2.5 vehicles. But we can't have half a vehicle, can we?
So maybe that's why they rounded to 3.
So that's why it's rounded to 3 and 5. Okay? So now the last one was what? What was along the x-axis?
10.4.
10.4 and 0?
Yeah.
What's 10.4 times 5? 52. So, again, that's ideal. Now, problem is we have partial vehicles, don't we?
Yeah, so.
So what you can do then is you could go back into this and you could find a whole number coordinate in here and substitute it in if you wanted to. But to do the answers, all I need you to do is do critical points. So this is the last step in the whole question. And that'll give you your maximum number of vehicles and your minimum number of vehicles. This one's sucky because it didn't work out right. All right? So to review today, you've already done this. Now you have an app to do it. So when you're doing these questions, that's the fastest way to use your app. Defining statement, X and Y. Restrictions, whole numbers, integers, real numbers. You have decimals. Objective statement, that's an equality statement. It's always going to be an equals to. That's your maximum and your minimum statement. All of these questions are maximum and minimum values. All right? This right here is the meat and potatoes of the whole section. Can you determine your constraints? Can you write the equations out? So here's what I am proposing to you. Everybody follow me here for 1 second? I am saying go through all of the questions in 6.4. Go through the first 4 questions and just write out this or that. Don't graph them right away. Do that as fast as you can. Check your answer, like just check the questions with somebody beside you, and then go back and graph them after the fact. Okay? Because if you're spending so much time graphing, you're not going to get through these questions fast enough. So what I'm saying is go through this process for 4 questions, then go back and graph those 4 questions, then do this again for the next 4 questions and graph them. You can use your app, sketch your app on a piece of paper. Okay? Were there any issues from yesterday? So this was 6, 1, 2, and 3 yesterday, right? You had a question, Brock, you thought?
Yeah. Number 7.
Page
51.
Okay. Becca likes to collect seashells on beach vacations. She's decided to limit her collection to 300 shells altogether. She wants white shells and mottled shells. Okay. So, let's say that for the heck of it, Brock, let's do our defining statement. So, X is what and Y is what? What's the X in that one? White shells? And mottled, is that correct?
Yeah.
Oh, that's spelled right. Okay. All right. Can I have partial shells?
Yeah.
Well, not really, but...
Okay, so then am I talking whole numbers or am I talking real numbers? Am I talking integers? What am I talking here? Can't have negative shells, right?
Imagine whole numbers.
Right. I get you know what the deciding factor is? Can you have negative shells? No. So then let's go with whole numbers.
This one could be,
Just like that. Okay? My next is my restrictions. I don't have an objective because it's not looking for maximum or minimum. So the last thing is my restrictions. Okay. So total number of shells possible is what? X plus Y is less than or equal to 300. Agreed? That's the most I can have. She collects only white shells and mottled shells and wants to have no more than 4 white shells for every mottled one.
4y equals 4x. Is that a restriction there and a restriction up there?
Oh, sorry, this is constraints.
Okay.
My bad. Mistakes this morning. Constraints.
But that almost looks like an objective statement, doesn't it?
Very similar to it, yep. Except there's an inequality in it. Okay, so let's look at this again. This is how I approach this, because I get confused with this all the time. So I say to myself, she wants to have, let's ignore the inequality for a second. She wants to have no more than 4 white shells for every mottled one. Okay? So if I have 1 mottled shell, what's the maximum number of white shells I can have? 4. But I could have 2 or 3, right?
Yeah.
Okay, if I have 2 mottled shells, how many white shells can I have?
8.
Up to 8, but it could be 5, 6, or 7, right? If I have 3 mottled shells, what's the maximum number of white shells? Less than or equal to 12. So, how am I getting this? How am I finding out how many white shells I have? X
Equals 4y.
equals 4y. So far, right? Because I have to take 4 times my mottled shells to get my x. Now, is it a greater than or equal to?
Yes. Well, it's a less than or equal to.
That wasn't a yes/no question.
Oh.
Is it a greater than or equal to, or a less than or equal to? How do I determine that?
No more than.
No more than.
So less than or equal to x.
X has to be less than or equal to 4y. My white shells has to be less than 4 times the mottled shells. Does that sound right?
Yeah.
Help me here. I want a consensus. This is the money one. This is the one that's going to cause the problems. It always does. So, does that look right to us?
Yeah.
The number of white shells will be less than or equal to 4 times the mottled shells. Is that what it said?
Yeah.
But it used a confusing thing like no more than, right?
Yeah.
So that's the hard part. The wording, the English part. There's your 2 equations, Brock. Now you can graph them. Okay, no problem. Use your app to graph it now, then put it on paper. Okay?
Are we?
Oh, one last thing. Sorry. Ro, go ahead and ask your question.
I
That's
said,
it.
will we be able to use this on like
Yes.
assignments and tests?
Yes.
Nice.
Okay? We haven't talked about this. I'm going to do this very quickly. Domain and range. All right, we did a lot of this last year in grade 10. Domain and range. What is domain? Can't remember? Yes. More or less, yes. Okay, by definition, domain is the set of all the x values on your graph. Okay, so all the set of the x values. Now, how do I determine domain? I look at how far left does my graph go to how far right does my graph go. Now, a line. If I draw a line on here, like that, how far left is it going?
Infinity. Negative infinity.
Negative infinity, right? How far right is it going? Positive infinity. So one of the ways we could write it was negative infinity to positive infinity, like that, with round brackets, because it's not including. Remember this? The other way I could write it was with squiggly brackets, x such that x is an element of all reals.
No, that's not it.
No, I don't like that one.
Okay? Now, x is an element of all reals. That's almost every time you have a line. All right? The range. How low does this graph go? Negative infinity. How high does it go? positive infinity. Squiggly, y such that y is an element of all reals. Now, where the squiggly brackets help you is if your graph is not continuous, if it's disjointed, meaning you have parts. Otherwise, I use this all the time. Now look at a question that we did today. It said, I want all whole numbers now. I can't do this guy with whole numbers. So I need to use squiggly brackets. All right? So I would write this, if it was all whole numbers, my domain, x such that x is an element of whole numbers. That covers everything. All right? That covers that there's no negatives, that is 0 to infinity. X is an element of whole numbers. Okay? Range,
So,
y such that y is an element of whole numbers. Okay? We'll do more with that. I want you just to focus on what we did today. But I wanted to show you what domain and range is. Okay? All right. I'm sorry I took a lot of time today, so you'll get more time tomorrow to do 6-4 and 6-5 together. Okay, but there's no more, you don't have to learn anything else. You don't have to learn anything else in 6-4 or 6-5 now. You're doing the same thing, and including 6-6. You're doing, everything's the same all the way through. You done? Everything's the same all the way through. You're just using your app now. And then take your app and graph it on paper. Okay, so basically what I tell people, screenshot your app to paper. Okay, and write your key coordinates in. All right? Okay, so you have the rest of the class and tomorrow to work on this.